All right. So in this chapter 10, we're dealing with two population means or two population proportions. So the reason why this occurs is because studies often compare two groups. So for example, aspirin's effect on heart attacks. So a group is given aspirin and another group is given a placebo. Okay, the placebo is your control group. Diet and exercise. So a group is given diet and exercise, and a separate group is given no diet or exercise. That's your control group. Political votes. So a proportion of people from different income brackets who vote for candidates. Let's see, a prep course effect on passing SAT and GRE. So a group takes a prep course, another group does not. That is your control. Okay, so of these groups, you have an independent group and a dependent group. Independent groups are where the samples are independent. So this is where you've got a test of two population means or a test of two population proportions. Dependent groups are matched or paired samples. So tests of two populations by testing one population and then looking at the differences. This is, the thing that I was talking about, which is section 10.4. This stuff is 10.1, 10.2, and 10.3. Now, when we formulate null and alternate hypotheses, you could see it in a couple of different formats. So, for example, the term mu1 minus mu2 is the hypothesized difference between two population means. If one is testing a claim where there is no difference between population means, then mu1 minus mu2 is equal to 0. So if there's no difference between the population means, if they're the same number, then if you subtract them, their difference should be 0. Right? So if the population mean in one population was 8, for example, and the population mean for the second population was also 8, then mu1 minus mu2 is going to be equal to 0, right? 8 minus 8 equals 0. Okay, so you could see something like this written. So likewise, if you do a little bit of algebra, so if we had mu1 minus mu2 equals 0, and if we add mu2 to both sides of the equal sign, these will add up to 0, and you've got mu1 is equal to mu2. So, you could see the expression of there being no difference between the two population means written that way, or here this is saying there's no difference between the population means. So to give you some examples, if we had a null hypothesis where the population mean of the first population is less than or equal to the second population mean, I'm sorry, the population mean of the second population, that's equivalent to saying that the null hypothesis is the population mean minus the second population mean is less than or equal to 0. So all we did in this case, come on, pen color, please change. There we go. Is if we had mu1 less than or equal to mu2, and we decided to subtract mu2 from both sides, okay, then a positive mu2 minus mu2 would give us a 0. And on the left-hand side, we would have mu1 minus mu2, which is what that is. mu1 minus mu2 is less than or equal to 0. So all we did was start with this, right? That was this part. We started with this, and we just used a little bit of algebra to rewrite the equation in an equivalent form. So all I'm trying to demonstrate here is that you might see a null hypothesis in either one of those two forms, and they're equivalent to each other. Just two ways of saying the same thing. All right, so an alternate hypothesis written this way, if we were to move mu2 over to the other side, this is what it would look like. Now, this is also implying here that the mean of the first population is larger. Because if you look at the way that this is set up, the mean of the first population, if this were 10, and let's say the mean of the second population was smaller, it was 8, right? 10 minus 8 is going to give you a positive 2, and positive 2 is greater than 0. Come on, eraser. Whereas if this value, if the mean of the first population wasn't larger, what if it was smaller than the second one, like that? Then 8 minus 10 will get us negative 2, and negative 2 isn't greater than 0. So it would make this an untrue inequality. So in order for this inequality to exist the way it is, this first mean, the mean of the first population, would invariably have to be a larger value. All right. So taking this apart algebraically, is a little bit more advanced. And this may not make as much sense right now, but you do need to keep this in mind because different homework problems, authored by different people, could have alternate hypotheses written this way or alternate hypotheses written that way. So you just have to be aware of it and keep an eye out for it. Okay. All right. And all I did here with, these other examples here is instead of less than or equal to, what if the null was greater than or equal to? Then it's going to look like that. What if the null hypothesis was equal to? Then the null hypothesis could be written with an equal to that way. Okay. Most of the hypothesis testing I think we're going to be dealing with is going to be where their difference, is 0. But if on the occasion we were testing a claim that the difference between population means is greater than some value, k, okay, where that's not 0, then we're going to use this term instead. So, here you don't see whatever value is part of the claim. But here we're saying that the difference between those two is less than or equal to 4 instead of less than or equal to 0. And the way that that would come across in a word problem is if in the word problem it said the mean of the first population is larger by 4 than maybe the mean of the second population, right? If the problem had said something like the mean of the second population is smaller by 100, it's smaller by 100 compared to the mean of the first population. And that would result in an alternate hypothesis that looks like that. Yeah. You have to do some mental gymnastics to translate how this equates to that. And that just comes with practice. Um, okay. I don't think you're going to see this very often, I think, in my homework, but there could be a skill work, that might have something like this. So just be on the lookout for that. And you can see here now that we're dealing with hypothesis tests of two samples, it does element or it does introduce an element of more complexity, which is why I think it's better to go to section 10.2 where it adds even more complexity all at once. So let's just deal with the complexity of dealing with two samples first. And then once we get a handle on that in 10.2, then we'll add just a little bit more in 10.1. Okay, so let's stop here. Let me know if you have any questions.